Is everybody with me? And this was really good. We use this when what we are estimating a p, estimating a proportion or percent. Okay? And when we think about it, some of those things that we estimated, like the type of variable that we were estimating using a percent was a qualitative variable. Okay? Now we're going to estimate quantitative variables, which means we're going to estimate means. Okay? So we talked about remember we talked about statistics and parameters? Okay? Our statistic when we're estimating a mean is x bar. And our parameter when we're estimating a mean is mu. Okay? So now what we're going to do is come up with an interval that we think mu, that true population mean, is in, using a sample mean. Okay. So now my margin of error looks a little bit different. It is going to be z times sigma over the square root of n. Remember that sigma is the population standard deviation. And what do you think my point estimate is going to be? What's my best guess at what the population mean is going to be? That's a really good guess of what my sample standard deviation would be. But the best guess at my population mean is my sample mean. Okay? So my point estimate is going to be x bar. Okay? So essentially, and this is the formula that's actually on your formula sheet. My interval is going to be x bar plus or minus z times sigma over the square root of n. So far, are we feeling okay?
Yep.
Sweet. Okay, so let's look at this one. You guys, this is 50, not 5. The dash sign is next to the 0. Okay. You guys, according to this, what's the point estimate? 30 pounds. Because that was the mean of my sample. Yeah? So you noticed before that when I asked before, I was like, oh, I'm going to be very specific on whether or not you use p hat versus x bar. Is everybody with me? Here's why. The minute I see that x bar, that tells me I'm using this formula instead of the other ones we were using. Just cool? Okay. So, construct and interpret a 99% confidence interval. So, we need to find the z for a 99% confidence interval. .58. You guys, at this point, do you feel comfortable finding that on your own, or do I need to take you guys through how to find that? Okay. 99% confidence interval means middle 99%. So then we say, well, what is this tail? And in this case, the two tails need to add to 1%, 0.01, so you cut that in half. And then you do the inverse norm of that value, of that 0.005.
You're assuming it's normal.
We are assuming norm, especially because the sample size is 50. Remember that we talked about before, the sample size above 30 is good. The other thing is, if the sample looks like it could have come from a normal distribution, we sometimes assume that, and then it's good. Okay. You guys, so my interval is going to be 30 plus or minus 2.58. What was sigma? 4.5 over the square root of 50. The margin of error is that amount.
That's what is this again?
This is the interval estimate. This is where the actual estimation is. Okay. So can we do this? Like, can somebody do the minus and somebody do the plus for me, please?
Plus is 31.64.
So that would mean the minus is like 28.36.
Yeah.
And interpreting that, we'll say with 99% confidence. We can say the population mean weight of 3-year-olds. So notice I'm using a lot of context, right? And in this case, guys, what was my margin of error?
You can find this right in the z-square minus.
So one way you could do it is 2.58. Like, you could just do that part.
It's 20.64.
Okay, so that's one way you could do it. Okay. The other way you could do it is you could say that I know that 30 plus that error is equal to 31.64. And so you could just subtract to get there as well. Whichever way makes the most sense to you, I'm fine with. Likewise, you don't necessarily need to calculate this by hand, right? Just like for the z-interval for proportions. Should I try to scare you? Okay.
Go for it. Wish you could take this. I'm not just gonna
I hate-
put them in my card.
I hate getting the hiccups. If I go to stat and go over to those tests, okay? And now if I choose number 7, z interval, so number 7 is a z interval for a mean, A is a z interval for a proportion. Okay, so both of them are there. So if I choose number 7, we're doing this from summary stats. Okay, we know the population standard deviation is 4.5. Our sample mean was something. 30, thank you. Our sample size was 50. And our confidence level is 0.99. Same interval. Cool? Okay. Now, let me see. Did I do this for you guys or no? Okay. So let's say instead of giving you what the mean was, let's say I gave you just a list of numbers. Okay? if I just gave you a list of numbers, what you would need to do, or what you could do, is you would put those numbers into your calculator, and then when you do that test, all you would need to do is tell it where you put the data, put in that population standard deviation, and it does everything for you. It'll tell you what X bar is at the end. It knows your sample size from the list that you put in. Yeah.
When you just did it with the calculator, were you still hitting A for?
No. 7.
Okay.
So again, Andy, when we're looking at it, we want to look at that's why it's really important again that we think through. This is X bar. Okay. So this Z interval is for the X bars.
Okay.
This Z interval is for the proportions.
Okay.
And so the whole idea of the symbol you're using tells you what you're looking for.
Okay.
And which procedure you need to go through. Okay? All right. Now, kind of like what we did yesterday. A lot of times we need to find the sample size we would need to get for a certain margin of error with a certain level of confidence, because that's really how people set up, like they determine how big a sample they need before they do anything. Okay, so this formula also on your formula sheet. So guys, when I ask you for sample size, you want to use the formula that gives you n. So it'll have an n equals. Do you guys see what I'm saying? And then you have two n equals formulas in your unit 7. Okay, one says for means, one says for proportion. So you have all this information, you got to use it. Okay, so let's say we want to be 90% confident and with our margin of error within 2 years, and we know the standard deviation of all the ages at Columbus State is 17.4. Okay, so we know sigma. We know within 2 years tells us that we want our E to be 2. Can we find Z? We good? This is making sense. Okay, so what's n? It was 203.58. Okay. Remember, n really just has to be greater than or equal to that amount. So n really has to be greater than or equal to 204. You will lose points if you tell me n is a decimal, because it suggests that you don't know what you're finding. Okay, so you need to round it up to a whole number. And it's always up. Okay. Perfect. Can you guys give this one a shot? Yeah, because dollars can go into. But you're finding sample size. So your answer isn't dollars, right? Your answer is N.
What's the mean balance? With
J-
is it not a balance? Predict the mean balance.
Within. But we need to figure out, but what are we finding? Right, when you're finding anything N is whole numbers. Yeah.
Oh, would it be equal to, or
I mean,
I don't know.
in the, so because I say determine, so like if I said determine the minimum sample size, the answer would be 39. Determine the like I don't see myself being super picky about that. It's just to help you recognize why we round the way we round. Okay, you guys, I'm done with 7.3. So here's the deal. If you guys look, we just did what we were going to do on Monday. I believe what's going to happen now is you will have the entire block day to do the lab, and then you will have Thursday to do the homework in class.